Hi, I'm Layla.
I'm Sadie.
And I'm Anne.
And we're doing our project on lightning rods, their origin, their function, and how they relate to what we learned so far in Physics 102.
Lightning rods are made to shield a building, property, or structure from direct lightning strikes and, more notably, any sort of combustive damage caused by the severe discharge of electricity. Made of a conductive metal such as copper or aluminum and risen up off the structure slightly to attract the lightning to strike it, protected devices such as lightning rods only catch lightning strikes and provide the dangerous electrical discharge a conductive channel to travel and then safely diffuse the electric energy into the earth through a process called grounding. Essentially, lightning rods offer a low resistance path to the earth, which then disperses the current. If lightning strikes, the system tries to securely transport the dangerous electrical current to the ground and away from the building. It is crucial that these parts are securely attached to reduce the likelihood of escaped current which could damage the structure. Lightning rods trace their history back to 1749, Pennsylvania, wherein Benjamin Franklin was fascinated by the complex notion of electricity, including that of the intense electrical current generated from storms or lightning. The idea has not strayed throughout the past few centuries, as Franklin had originally utilized metal, such as iron, to attract lightning strikes from tall structures, for example church steeples, to study the nature of lightning. From this innovative discovery, in which grounding techniques could prevent damages to homes, lightning rods, also called lightning attractors, or Franklin rods, became immensely popular in urban and rural settings.
Lightning rods are placed at the highest point of a building to provide a low resistance path to the ground if hit by a lightning strike during a thunderstorm. It's placed at the highest point of a building because lightning tends to strike the highest object in its vicinity. Once the bolt strikes, the rod is able to safely channel the volts of energy through its cables around the building and into the ground, into a conductive grid buried in the ground nearby. This conductive grid allows for grounding to occur, a process which lets the charge carried from the lightning rod to be safely dissipated into the ground. This then protects the building from the massive energy surge that results when something is struck by lightning.
A key takeaway from the study of Chapter 16 in the textbook was learning about the behavior of charges. The founding idea that informs how all charges interact is that opposite charges attract. From this principle, we can explain the phenomenon of inducing charge, where we can create charge separation in an object by introducing an external charge in the area of the object. Most simply, we use the example of the ball and the rod. If we were to bring a positively charged rod near a conducting metal sphere, the negative charge in the sphere would gravitate towards the rod. This sends the positive charges away to the other end of the sphere, creating two poles of the sphere. We also learned that the Earth itself can act as a reservoir in which charges can go to or come out of in any quantity. Therefore, if we were to connect a wire from the charged sphere to the Earth, charges are free to flow through the wire in order to create a less unstable object, which is the main principle observed with grounding. It is in this way we can manipulate charges of objects by using the Earth, which is the phenomenon called grounding that Anne explained. Since the lightning rod is connected to the ground, it is free to access the Earth's reservoir of charge that we learned about in class. The charge gained by the rod by a lightning strike can immediately be directed into the ground instead of passing through the building the rod is on, which can cause fires, explosions, or electrocution of those inside. Additionally, lightning rods must be made from conductive materials and are commonly made from copper and aluminum, which have low resistance and excellent conductivity. This means these metals do not resist the flow of current, and free electrons can easily flow through them. Since we want the charge from a lightning strike to freely and easily flow into the ground, it makes sense that we would want lightning rods to be made from strong conductors like these.